Hi, welcome to a video on solving exponential equations with the power of the base as an irrational number, part 1. Solve for x to the nearest hundredth. Notice that 5 to the x equals 28, so let's look. 5 to the 1 is 5, 5 squared is 25, 5 cubed is 125. So 28 is between 25 and 125. So that means the power of x is between 2 and 3. So the only way to find that would be to do the log of both sides. So we do the log of each side. And because of the power rule, x moves to the front of the log 5. And now we divide each side by log 5. Cancels, so x equals, so let's look at working out the log of 28 divided by the log of 5. The log of 28 division, and we do log 5, and it's 2.07 to the nearest hundred, so 2.07 to the nearest hundred. Notice, let's bring back this number again. This is this number here, 2.070415071. This continues on, but the calculator stops. But it's an irrational number. So if I wrote this number, or if I did, say, 5 to this power, so let's do 5, and power button, and pick up the answer. So the answer is second function here, like here. That's the answer that I just had, which is an irrational number. That would give me 28 right on. But because we do 2.07, so 5 to the 2.07 is going to be approximate, not going to be exactly. So let's see. 5, power button, so 2.07 should give me close to 28. So it's 27.9813, so it's close to 28. Because we rounded 2.07 off to the hundredths, then this is close to 28. So that's one. So notice we have the x's in the exponent, so we have to do the log of each side. And here's another one. Again, x is in the exponent, so what power of 3 will give you 68? So 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, so somewhere between 3 and 4. So we do the log of both sides. And the exponent moves in front, the power. So this is x minus 4, but you put it in brackets. Get the log of 68. Now we divide by the log of 3 on each side. That's what I do. And I get an x minus 4. So the log of 68 divided by the log of 3 is, if you use your calculator and check it out, remember you can pause your video and work this out, so that's to the nearest hundred. So x equals 3.84, add on 4, so it's 7.84. That's an approximate, and just as a little check, so x is 7.84 minus 4, so 3 to the 3.84, and just as a check, 3, power button, 3.84, and we get 67.94, which is close to 68. Okay, we have another one to do. Notice this x is on both sides, but x is in the exponent, so we have to do the log of both sides. That's done. And because of the power rule, 3 to the x moves in front, the log 2, and the x plus 1 moves in front of the log 5. And again, we can divide by log 2 on each side. So we get that cancels, we get 3 to the x equals x plus 1. And log 5 divided by log 2. Log 5 divided by log 2 is 2.32. And let's just check that. Clear. Log 5 division log 2. And we get 2.32 to the nearest 100. This is less than 5, so we leave it as a 2, 3.32. And we take our time and solve for x now. So 2.32 times x, 2.32 times 1. Move the x's to the left side. Done. And we subtract that, and we get 0.68. X equals 2.32. And we divide by 0.68. So x equals, and we divide that with a calculator, is 3.41 approximately. So if you check that out, you'll find that they will come close to, both sides will be the same approximately. Okay, let's try another one. Solve for x to the nearest 100. Again, I did a variety of equations, and x is in the exponent, but we have to bring the 7 over, add it on, so 2 to the 3x equals 70. So we divide by 2, so 3 to the x equals 35. Now we have x is in the exponent, so now we can do the log of each side. And as a result, the x moves in front, so it's x log 3 equals log 35. Divide by log 3, and divide by log 3 on each side. Cancel, so x is equal to, so the log of 35 divided by the log of 3 is 3.24. And if you plug that in here and work it through, you'll get close to 63. Now we have another equation that's a little bit different, but this is a multiplication of exponential. Notice the two bases are the same, so that means I can add up the exponents. So that gives me 2 to the 2x plus 3 equals 107. And again, x is in the exponent, so I do the log of each side. And the power goes in front, so 2x plus 3 log 2 equals log 107. And I divide each side by log 2. They cancel, so I get, let's say 2x plus 3 equals, and the log of 107 divided by the log of 2 is 6.74 if you use your calculator. So 2x equals 6.74, subtract 3. 2x is 3.74, and divide by 2, x is 1.87 approximately to the nearest 100. Remember, going to the nearest 100. So when I divide this, I round it off to the nearest 100 and then solve for x. Again, if you sub 1.87 here and 1.87 here and work this out, you will get close to 107. Remember, the value you get is an irrational number. Let's continue. We have another equation that's a little bit different. I try to do different equations. So we have the 2 raised to the log of 3 to the x base 3 equals the log of 125 to the x. So we have 2, so the log of x base 3, when the base is 3, is an x. And there's a rule that we did earlier, so b to the x with a base b. If you have the log of b to the x with the base of b, then the answer is x, so that's an x. So what's the log of 125 base 5? So the answer is 3. So knowing these rules, We simplify it. Now we do the log of each side because x is in the exponent. So we get x log 2 equals log 3. And we want to solve for x, so that's a multiplication. So we divide by log 2. Cancels. So x is equal to. So the log of 3 divided by the log of 2 is 1.58. Maybe check your calculator. Pause the video. And I'll just do that one for you again, just to keep everything okay. So we have the log of 3. Notice I got the bracket division. Log 2. The 2 is enclosed in a bracket. And I get 1.584. This is less than 5, so I keep it as an 8. And again, if you put that back here, it'll verify. Now we have another one that's a little bit different. We have the sum of logs and the difference of logs. But before I do that, I always do the power rule first. So this is the log of 4. The x moves to the power of 5. I always do the log power rule. Any number that's in the front of a log goes to the power. So we have that done. Now the sum of two logs is the log of the product. So that's 4 times 5 to the x. And the subtraction of two logs is the log of the quotient. So that's 400 divided by 2, which is 200. So now we got the log of each side, so we cancel the logs. We can say 4 to the 5x equals 200. And notice we have 4 times, so we divide by 4. We get 5 to the x, 4's cancel, equals 50. Now we have x as an exponent in the exponent, so we have to move. We do the log of each side. The reason is to bring the x down in front. So by doing the log of each side, we get the log of 5 to the x equals log of 50. So x times log 5 equals log 50. Divide by log 5. Cancels. So x is equal to the log of 50 divided by the log of 5. And we work that out. And I was going to write that down again, but I won't. That's just a 2.29. Check it out. And I'm rounding it off to the nearest 100. Again, notice the problems are a little, I vary the problems to help you see more examples and understand. Solve for x to the nearest 100. And again, you notice that we have 18,000 equals 2,000 times the base 1.04 raised to the x divided by 2. So we divide by 2,000. And that cancels. Zeros cancel, and we get a 9. So 9 equals 1.04 raised to the x over 2. And I like to change it around. I like to go 1.04 to the x over 2 equals 9. Now I do the log of, I didn't have to change it around. I just could have left it x over 2 log, because of the power rule. The power exponent goes in front of the log. Now I divide both sides by log of 1.04. They cancel, and I get x over 2 equals log 9 divided by the log of 1. I don't need that bracket there. And we cross multiply, so we get, so notice we get x log 1.04 equals 2 log 9. And we divide by the log of 1.04. That cancels, so x is equal to, now we can plug that in, 2 times the log of 9 divided by the log of 1.04 will give you 112 0.04 to the nearest tenth. And again, problem's a little bit different. And ended off with a good problem. Again, you can put 112.04 in place of x, divide by 2, raise 1.04 to this power, times 2,000, you get close to 18,000. Now we have another one, but we have fractions as the exponents. Again, the bases are different, and we have to do the log of each side. Okay, we do the log of each side. That will bring the exponent, where the x is, down in front. So we get x plus 1 over 2 and log 3. And we get x minus 2 over 7. And then that's log 5. Now, if I could divide, but what I'm going to do is go x plus 1 over 2, and the log of 3 works out to be 0.24, and x minus 2 over 7, the log of 5 works out to be 0.70. Just to check, the log of 3, just to check, note to make a few errors. So it's a log of 3. Something happened there. Let's see. Log 3. Did I punch the wrong number? 0.4. Okay. 0.48. Okay. Yep. 0.48. Everything is okay. Let's do the log of 5. Sometimes we make an error. Log of 5, and I got to be careful. And the log of 5 is 0.698, so it's close to 0.7. Now we divide by 2, we get 0.24. Divide by 7, we get 0.1. Multiply 0.4 times x. 0.4 times 1. 0.24, sorry. And 0.1 times x. 0.1 times negative 2. Negative 0.2. Bring all the x's to the left side. And bring the constant or the numbers to the right side. Change the signs. So decimal 24 subtract decimal 1 is 0.14x, and that's a negative 0.44. We divide by 0.14, and they cancel. I get x is equal to, and you can use your calculator, but I'm just going to do a little tiny bit of math here. That's a negative. Multiply by 10, I get 44. Multiply by 10, I get 14. And divide by 2, I get a negative 22 over 7. And so that negative 22 over 7, let's see, 22 division 7 gives me 3.1428. And it's almost like a pi, 3.14 to the nearest 100. Or I could have done a negative 0.44 divided by decimal 14, and I would have still had 3.14. So sorry about that little mistake there. The log of 3, just to check, the log of 3 right here. The log of 3, just to make sure. The log of 3 is 0.48 to the nearest 100. Correct. So everything works. So if you take 3.14, put it right here, add on 1, divide by 2, you get 3 to this power. And if you take the 3.14, subtract 2, divide by 7, you get a power. So 3 to this power is going to equal 5 to this power, and they should come close. You can check that out by pausing the video to make sure, but I know that, well, I'll do it. 3.14, that makes it 4.14 divided by 2, and this is 5. 3.14 subtract 3.14 subtract 2 is 1.14 divided by 7. So again, you got to round it off to the nearest hundred. So clear that. So 4.14, that's a 2.07, and 1.14 division 7 gives me 0 to the nearest 100. So let's see if we're right. 3 power button 2.07, and that gives us 9.72, and 5 raised to the 0.6 is, oh, so we have an error. Where is the error? 3.14 add on 1, that's 2.07, and 3.14 subtract 2 is, so just check those numbers. Check the numbers there now. By checking sometimes. Okay, that's right. And let's see. 3.14 subtract 2 is 1.14. So 1.14 division 7. Yeah. Oh, something is wacky weekly here. I forgot the negative. Look, I forgot the negative. It's the negative on that. That's why it didn't work. So by checking, we check it out. So again, if you take 3.14, so that's 3, add on 1 is negative 2.14 divided by 2, and 5 is a negative 3.14, so it's a negative 5.14 divided by 7, so that's 3 raised to the 1.07, and 5.14 divided by 7, 5.14 division 7 is, oh, better be careful, 5.14. Once you make an error, it's hard to get back under the, and that's a negative, so it's decimal 73. So let's see if we're right. 3 power button negative 1.07. So it's decimal 308, and we keep on going. And 5 raised to, there's the power button, that's a negative 0.73. Hey, we got the right answer, so we're okay. So you can see we're okay here. And notice when you plug this in, just on the calculator here, when you sub this in, this is a subtraction. This is a negative, like a 4 to the negative 2. That's a negative, as in a negative number. That's a subtraction here, difference. So a little error. I forgot to put the negative there. By checking it out, I found that I had the wrong answer. I had a positive, so it should have been a negative. So sometimes when you're doing problems, you have time, checking the answers verifies if you're okay. And if you like my video, click on the like button. If you're not a subscriber, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.